Hello, this is lesson 8.2 in your Geometry Part 2 textbook talking about special right triangles. This particular problem is found on page 500 of your textbook, and we're literally finding the length of a leg, but there are two special right triangles. There's a 45-45-90 triangle, and there's another special right triangle that we have to memorize, and that is a 30-60-90. Since this one is a 45-45-90 triangle, the relationship between the legs of a triangle, which both happen to be the same for a 45-45-90, the relationship between the leg of a 45-45-90 and the hypotenuse of a 45-90 is the square root of 2. So what I'm trying to say is that the hypotenuse of a 45-45-90 triangle is the square root of 2 times bigger than the leg. So that's where they're getting this right here, that 6 is equal to the square root of 2 times x. It's always the leg times the square root of 2 always equals the hypotenuse. So if I divide both sides by the square root of 2, which is this step right here, of course I can't leave a radical in the denominator, so I end up multiplying by the square root of 2 over the square root of 2. Now remember, that is really just another form of 1 because any number over itself. So we're not changing the value of the problem, we're just changing the way the problem looks. And at the same time, we're eliminating a radical out of a denominator, which is just a mathematical no-no. So 6 times square root of 2 becomes 6 square roots of 2. The square root of 2 times the square root of 2 becomes square root of 4, which translates into just a regular 2 here. So then the 2 here will cancel with the 6, and that's where the 3 comes from. So my answer actually becomes x equals 3 square roots of 2. So the answer would be choice B right here, if you had a multiple choice question. Okay. Now let's look at the got it section. It says the length of the hypotenuse of a 45-45-90 triangle is 10. So what is the length of one of the legs? Again, you don't have to draw a triangle. I just want to give you a visual of what I'm talking about. If this is 10, what is one of the legs? Again, the same way as the first one was set up, the hypotenuse is always the leg times the square root of 2. So if I put 10 in for the hypotenuse, and I'm looking for x, or you can call it L if you wanted, x squared root of 2. I would first divide both sides by the square root of 2. I can't leave the answer. That would leave me with x equals 10 over the square root of 2. I have to do what's called rationalizing a denominator. That's going to end up giving me 10 square roots of 2 on the top. And for the denominator, it's just going to give me a regular 2. And then, as I showed you before, that 2 will reduce that 10 to a 5. So my answer ends up being 5 square roots of 2 over 1, or just 5 square roots of 2. Okay. Now, the second part said in problem 2, why can you multiply 6 square roots of 2 by the square root of 2 over the square root of 2? And again, I shared this with you before. But first of all, that by doing square root of 2 over square root of 2, it will help you eliminate the radical out of the denominator. But secondly, you can do it because you're not changing the value of the problem, because any number over itself is simply just 1. And therefore, you're not really changing the value of the problem. Hope this was helpful.